when you're comparing how fast things grow, I want you to think about this graph. And so I want you to notice the scale on this graph. The x-axis is very slow, right? It just goes up by 1, 2, 3, 4, 5, 6, 7, 8. But the y-axis is changing rapidly, right? So like the y-axis is up to 4,096. And so when you think about this graph, you think about which ones are at the top near the end, right? So you kind of ignore this part of the graph over here where stuff is changing. Sort of ignore that and think about which ones are at the top. So what you see is that 1, this is called constant complexity. It's just doing one operation, is the fastest because it's at the bottom, right? It goes the fastest. It doesn't take a lot of time. Whereas n factorial, this is really slow. It takes a lot of time. It takes a lot of operations. So this is really slow. Or this is the highest complexity. So some things to keep in mind as we go up the chain here, the powers go up. Polynomials come down here. And then comes exponentials. And then comes factorials. So when you're making just sort of a complexity chart, this is increasing complexity. Think about it as constant, and then log n, and then polynomial, and then exponential, and then factorial. So as you go this way down the chart, it is a more complex algorithm. It takes longer to run. So this is these are slow running down here at the bottom because they're the most complex. They have the most operations involved in them. And this is fast running. Anytime you multiply something by log n, multiplying by log n makes it a bit more complex or slower. So what we could say is that n squared is faster than n squared log n. And so when you think about the O of f of x is O of g of x, what I want you to remember is that the one in here is larger and the f of x is smaller. So this is smaller on the graph here, this graph, and this is the larger one. Okay, so when you're doing the problems that ask you about is something O of x squared, so is f of x O of x squared, then you want x squared to be at least as big as f of x. If it says is x squared O of f of x, then you want f of x to be bigger than x squared. Okay, so the one inside the big O is the bigger function. But keep this chart in mind, because this chart is going to be the one where you can see how things grow. This is in the textbook. It's in the notes. Keep this chart in mind.